Assalamualaikum warahmatullahi taala wabarakatuh. My name is Daniel Faiz bin Zulaini. So today me and my friend Zahir going to present to you on the failure analysis of composite using FRP with induced environment. So this article was written by the VF Fiore and L Calabrese in year 2020, entitled The Evolution of Bearing Failure Map of Flat Composite Laminates Aged in Marine Environment. As for the introduction, fiber reinforced polymer (FRP) has been replaced traditional material in several engineering fields, such as in nautical, aerospace, and even being used in sport equipment. Bearing stress evolution and failure modes, such as bearing net tension shear up and cleavage, were investigated at varying pin diameter and distance between the center hole and the sample free edge. This is crucial to understand on how exposure to the marine environment can affect the bearing behavior of pin FRP laminate, especially when the natural fiber flex are utilized as reinforcement. So in this case study, the sample used are using the 10 laminate of 2 times 2 twill wave woven flat fabric with a deck bar epoxy resin with a commercial name SX8 Evo. So, by following steps that have been learned in chapter 1 and the method that suggested by the textbook, we must have a layer analysis based on the characteristic and the material that we want to inspect. So, as the sample used is using the fiber reinforced polymer FRP, so we can say that the fracture of the material going to be from the composite material. So there are few mode for the composite material, and from my opinion, I suggested that as early analysis, the material we will having the bonding and the fiber will pull out. So the mechanism due to tensile overload, which is resulting to the shear fracture. As for the methodology of this experiment, uh, it is the time of aging in the salt fork is vary, which is start from 0 day, 30 days, and 60 days. As for the salt fork solution, using 5% of natrium chloride with pH ranging from 6.5 to 7.2 at 45 degrees Celsius. So the sample I prepare just like showed in the figure A, with a thickness 6 millimeter and length of 150 millimeter, and being set up with other equipment just like showed in the figure B, so that we can see the result of the fiber being pulled out as we make an early assumption. Uh, Next, you can see from the figure, it shows three different plot on the stress displacement graph, which is the FA is represent the zero aging day, while FB is 30 days of aging time and FC is 60 days of aging time. We can see from the pattern of the graph is that FA having higher stress, which is can withstand the higher stress compared to the 30 days and 60 days. And the area under the graph of 60 days and 30 days having bigger area compared to the 0 days of aging. So from the graph, we can say that the longer the aging time, the higher the displacement of the whole diameter. Okay, this due to the environment soften the composite allow to the shear stress happen. Then due to the high content of hemicellulose and cellulose, the presence of void and crack within thermoset matrix, the presence of marine environment slowly reduce the mechanical properties of the fiber, which then with and help of the stress that the fiber being used, which is then causing the shear out fracture, and then make the fiber to fail. So this is why the induced environment uh, can disturb the performance of a material.
Referring to the fracture image on the top, the figure 3A is an example showing the collapse area on pinhole contact surface area due to bearing failure and also cause shear cracks and delamination at layers interface leading to the mechanical joint stability. Figure 3B shows the 30 days age sample. Only local collapse compression caused by softening due to the humid environment exposition can be seen. And the figure 3C shows a different failure mechanism, which is due to the long exposition time, which is 60 days. The exposition to soft fault environment cause the net tension fracture takes place and stimulating the propagation of cracks at max stress concentration section. And there are appearance of fiber breaking due to the long exposition, which is 60 days. To soft fault environment. Okay, now moving on to the stress versus ED. The trend highlights that mass bearing stress increased by increasing ED ratio. For the region 1, it shows the initiation and propagation of fracture by shear out mode. For the region 2, the cleavage, which is catastrophic fracture mode, appear induced by a combination of shear out and net tension modes and usually triggered from joint edge rather than near to the whole area. For region 3, the ED is over 3, the max stress becomes constant and the pin-loaded laminate undergo a mixed fracture modes between net tension and bearing mechanism. And the characterization is done by SEM. The SEM image for A is unaged and for B is 60 days of aging. For the unaged, the debonding phenomena can be observed due to low compatibility between the hydrophilic flex fibers and hydrophobic epoxy matrix, lead to the bundle clusters with good interaction. And for the 60 days of aging, the damaged area are visible due to the interfacial debonding and triggering propagation of cracks that significantly reduce the mechanical performance of the flat laminate after long aging time. As for the failure mechanism map, it can be seen that bearing region is only for low aging times, and on the other hand, the net tension and shear out regions become more extended with increasing aging time. The flex fibers undergo significant degradation, which reduce adhesion at fiber matrix interface and mainly reduce the tensile strength of the fiber. In conclusion, the salt fault position alters the mechanical performance of the pin flex epoxy composite and also induce a reduction in the bearing area and the failure mode, thus favoring premature and catastrophic shear out and net tension failure mechanisms and also limiting the effective mechanical durability of the mechanical joint. The composite laminates need to be designed by selecting narrow range of values of specific geometrical parameters, which are ED and WD ratios, to avoid catastrophic failure. The environment thus affecting the fiber that mostly being used in many applications and reduce its properties due to the failure. For the recommendation of future works or studies, daily maintenance and checking need to be done to avoid risk to happen and apply suitable coating that resists to water absorption so that the mechanical properties can be preserved. That's all from us. Thank you.